Hey, I'm Kastan. I'm a third summer intern here at the NASA Langley Research Center, and I'm working on a robotic in-space assembly project. So let's go talk about that right now. So, about that project. Basically, satellites are getting so big and expensive and complicated that we need to send them into space in multiple rockets. So what we do is we send them up in multiple rockets and then get them into the same orbit, zipping around the Earth. And then once they're next to each other, we want to use robots to assemble all of those pieces into one large structure. We need this for complicated satellites and for missions to Mars, where we're just going to need a lot of cargo going into orbit. So I work on the robots that do the assembly. More specifically, I use little cameras like these, which have 3D depth information, and we turn information like this into position data so we can find the objects that we're looking for in the world. Once we know where objects are, we're able to pick them up with our robots and assemble them into the final structure. So I work on turning camera information into position information so that our robots can actually do the assembly. That's all. And so last year I worked on this project where we used these little fiducial QR code looking markers in order to find the trusses. But in space, every ounce of mass counts. So we want to get rid of this parasitic mass and transition to using those 3D cameras to just find the truss based on its intrinsic shape. And so that's how we're getting rid of that parasitic mass and then having a more robust system overall to replace it. But this is only quarter scale and with different hardware than we're going to end up with in the finale. So let's go look at what full-size robotic operations actually look like.
We're just getting more stuff.
Okay, so those robotic arms that you just saw there, those are just temporary hardware. The real hardware is super cool. It's this 30-foot long crane that's custom built to fly into space to move all these things around, but that's classified. So we can't really show that. What we can show, however, is all of these beautiful trusses. These are the kind of trusses that we're going to be assembling in space. There are a bunch of different types, but these will be up there as kind of the structure of the satellite. You can put large mirrors on top of this and then create something akin to the Hubble telescope or the James Webb telescope by putting mirrors up there. But you can also actually cover the sides of these with control panels and sensor dashboards and stuff like that. And so these will actually house sensor suites on the outside of them as well. So we're developing other robotics that'll crawl across these structures and then pick and place sensor suites as we add to these large structures flying around in space. Really what we want to do is create large systems in space. And to do that, you're going to need infrastructure. And so to have that infrastructure in place, we need autonomous robotics. So that's why we do autonomous robotics. Let me walk out of frame again. Hey, well, thank you so much for watching. I just wanted to say before we go that NASA really does a lot of cool research and it's worth funding. Also, if you want to be an intern here at NASA at any of our research centers across the country, you just have to go to intern.nasa.gov to apply. I applied when I was in high school and I got the job, and it's been one of the most transformative experiences of my life. So thank you so much to the NASA research centers across the country. My name's been Kastan. Go to space.